friends of FXM Motors, my name is Cristian Pirateque, and today I welcome you to this new section of the channel called FXM ESCUELA, in which we are going to develop a specific training and modules for each training. Because you have requested, this course is developed specifically for you, our community of friends of FXM Motors. We are going to start with a specific and total training on the PULSAR 200 NS and the PULSAR 200 fuel injection. We are going to talk about all its electrical circuits, all its diagrams, so I recommend that you don't miss these areas because we are starting from the most basic to the most complex. So, let's go!
FXM Motors, servicio técnico especializado en motocicletas.
Well, in today's module, we are going to start with a fairly simple electrical diagram, which is the third signal diagram. We are going to support ourselves with electrical diagrams of the workshop manual. So, we have here the diagram of the directional signals of the carburetor PULSAR 200 NS circuit. So, let's see that there is a series of symbols and cables here. So, we are going to explain them one by one. The first rule to be able to interpret diagrams is to identify the components. In this case, what are the components? We have a signal here, we have another signal here. Here we have the fuse box, here we have the battery, the mass of the battery, the flasher that I'm going to explain you. The kill switch, the red button, the emergency stop, that is in the right command. We have a turn signal switch that will be left and right directional buttons. Directional lights, those are front ones. This is the left and this is the right. Digital dashboard or digital speedometer, that is indicator on the instrument panel. And finally, we have the ignition switch, that is the key. This will be the diagram for the carburetor. For example, here I have the injection diagram that, as we can suddenly see, is a bit friendly because it doesn't contain symbols, but rather photos. Likewise, we have turn signals, the fuse box, the battery. The difference from the previous one has a light control module. That is, a light control module unit that is a hybrid unit where the integrated flasher is, as well as the left command, the main switch, and the dashboard. On this PULSAR fuel injection motorcycle, if we realize that is an important difference, and that is the kill switch is not there. In other words, the kill switch for the PULSAR 200 fuel injection doesn't interfere with the operation of the gas lines. That is why it is important to interpret the diagrams as well, and the current diagrams for that model of motorcycle we have. So the second element to identify, or the second rule to interpret a diagram, is to vary the masses. What are the masses? The negatives of the circuits. So we have these negative of the gas lines. Here we have the one of the right, the one of the left. From here we have another mass of the right front turn signal. Look at the ground of the instrument panel, and very important, the ground of the battery. Once we identify the masses, then we verify what the power source is. That is, what the circuit is going to feed us. In this case, the power source is very simple, the battery. The same applies to the other diagram of the PULSAR fuel injection. Ground here, see the grounds. These grounds are the common grounds. That is due to this black striped yellow cable. See, here is a common ground that connects them all. And finally, you have to follow the flow of the current. So for that, we are going to help ourselves with this software. That is the kill switch. That is, it is like the carbureted NS. So realize, here is doing a tour of the masses. Here we can see that he has already done a tour of the masses. What goes after the masses? We are going to follow the flow of the current. So see that it comes out of this V stripe B cable. All these stripes are cables. When in a cable, we find a point like this, that is here. This point means there is a connection. There is a splice. That is, the cable goes and there is another add cable. Two cables comes out of that single cable. So we are going to follow the flow of the current that comes out of the battery before that it goes through this 20 amp fuse. It goes out through the battery and see that the cable is divided here. The power is divided. One for the key switch and the other goes into the dashboard. So far, we haven't done anything. That's it. If we are going to measure the motorcycle at this moment with the switch closed, we are going to have 12 volts of the battery voltage on that white wire, W of white, which is the color code. The cable will be white, so it will have 12 volts. When we open the switch, let's see that we open the switch and the current goes out through this black wire. Oh well, I forgot to tell you something important. In diagrams and on motorcycle, it is very common and very normal for the wires to change color. What does it mean? See that here in the switch it is black, but then it changes to a brown with a blue stripe. So it is normal for them to change color. It is very normal. After a connector, that can happen. Usually in the manuals, they give us this information. However, if not, a specific follow-up must be made for each component lock. We follow the flow of the current through the blue stripe cable and see that here it was divided again. One goes to the 15 amps fuse and the other goes to our kill switch. We already know that the kill switch is the run, the red emergency stop button. Get to the kill switch, wait here. See that here for the brown cable and change of cable color blue stripe after fuse to brown. It enters to third signal relay, which would be a faster that the function of the flasher is to receive power, a direct current and send it intermittently. That is, with a few times is a flash. See that it comes out through an orange wire, OR of orange. From the orange cable, look where it goes for our left command. Third signal switch to the left command, and that's when, at that moment, there is power to all those components with the simple fact of open the switch. Now, let's follow the flow of current. So here, when the kill switch is activated, see that this current is going to come out. The one that came through the brown blue stripe is going to come out through the bright red stripe. And does it go where? Look, to the instrument panel, it will turn on the instrument panel. At that moment, we can activate the third signals. Here they are operating the left. So notice that the power comes out through the gray cable, and this power is divided where? For the right rear third signal and for the right front turn signal, an indicator of the instrument panel. So when you activate the left, the same. It goes through the green cable to the two turn signals. They light up and the bulb on the instrument panel also lights up, which follows the same circuit. Here it goes through this cable, there is a connection, here is another union, and all the consumption elements needs a mass and power supplied to function. In this case, the mass was already there, which was the first exercise we did, and the only thing missing was food. So this circuit, which is very basic, is a signal circuit. In this case, for the PULSAR 200 fuel injection, it is simple, the same as the activation for the third signals. We see here that the kill switch is not necessary, simple by operating the run. It goes out through this brown wire, it enters through this blue stripe brown wire to the fuse box. It goes out through this brown cable to the relay or the control unit, It goes out through this orange cable to the left-right turn signal command. And from there, the command activates. If we go through this cable, see this gray, there turns on the front directional rear, and there is also a feed for the instrument panel to turn on the instrument panel indicator. So in this case, this motorcycle, the NS 200 fuel injection, has a little bit a difference there. Okay, so this will be the theory. Now we go to the practice. Before continuing, I want to tell you all this training will be completely free. So we need that you please help us. How? By liking the video, subscribing to the channel, searching these videos. This really help us. Now the video follows. So as I said at the beginning of the video, here we have the components. So we have the battery, the fuse box, the main switch. Normally in the carburetor we will find a flasher like this, but in this model of motorcycle it is integrated into the light control unit, just like in the diagram we saw for the PULSAR 200 fuel injection. The left command that has the button for the turn signals, the indicator on the instrument panel, and finally the 4 turn signals, the 2 fronts and the 2 rear. Now we were going to identify the masses. This is going to be the main tool, rather it is going to be our best friend during all this process of training the electrical system. The multimeter. With it we are going to measure the different variables. Here on the scale of 20 volts direct current, we connect the positive and we are going to start taking the readings. So the mass of the battery is in parameters. We measure the mass of the turn signals. This is in parameters and this is in parameters. Let's see that the tip of the positive is on the positive side of the battery. Mass of the front turn signals in parameters. And let's not forget the mass of the instrument panel. Now it follows to identify the source of the circuit, in this case the battery, and then we are going to follow the flow of the current. So we put the masses and we begin to measure the source of the circuit. So we have 12 volts. From there it goes to where? To the fuse. We open the cover and take the readings on both pins, the one that goes in and the one that goes out. So battery fuse goes through this black stripe white wire and goes into our switch through a white wire and goes out through the coffee. In it, the current is through the white cable and it is not through the brown cable until we open our switch. It goes out through this blue stripe brown cable and goes back to the fuse box, and then it goes to the control unit through a brown cable, and we check input voltage and output voltage. It arrives through the brown cable and goes out through the orange cable. And as you can see, it is internally because it is already flushing its flashing function. And this orange cable goes to the left command, to the directional button, which is this in the command connector. And when activating the command to the left, this orange cable exits through the green cable for the 2 turn signals and the instrument panel. Still, the voltage is not static because the light bulb is turning on and off. There, what the multimeter is doing is taking an average over the minimum voltage and the maximum voltage because it doesn't have the capacity to take the reading and the update itself as quickly as the turn signal light bulb is on. Here it should give us the same voltage and the instrument panel indicator. And when you turn it to the right, it comes out through this gray cable, the same to the front, to the rear, and the instrument panel. Normally, actual diagnosis should be measured with the mass of the component itself. Well, we have already validated that it had a separate mass, but it is always recommended in a real diagnosis to measure the component with its own mass because sometimes the mass is inefficient, or then we realize that the voltage is not reaching well. We disconnect and see that the voltage they are there then because we can have a sulfatation or a botched cable. This is happening a lot. In this case, we have that the turn signal has the same voltage as the left ones. Here we should not care the back voltage and the instrument panel. So once we went through the entire circuit, in reality, we verify the voltage. We see that there is voltage in the 4 directional signals in the light bulbs when the left command is activated. I want to tell you something very important, and I want us to see the blinking frequency of this left turn signal with the sequence of the right turn signal. As we can see, it is completely different. This is called, or is often called, hyper flashing. and I'm going to explain you why. I need to give you context on issues of current consumption. For that, we are going to do some amperage tests, and these amperage tests are done to determine the consumption of each element. To do it, what we are going to do is break this circuit. That is, we are going to cancel this fuse, we are going to connect the two leads of the multimeter, and we are going to measure the number of amps that pass through this circuit. In the basic electricity indicator module, I am going to explain you these modules in a little more detail. For now, we are going to do this reading on the motorcycle. So we remove the main fuse, the 20 amps ones, and with the multimeter, we are going to make that series circuit. For that, it is important to change the place of the tips, because here the maximum scale of 10 amps is measured and the maximum scale is logged for in the multimeter, which is 10 amps. But to make this measure ironically, I can't do it with this multimeter because at some point they measuring wrong. Either they didn't change the leads or they log at the current scala and they burned that function. So I have to use this other multimeter. So here, returning to the same amperage tests, 10 amps, which is the maximum that we are going to measure it, and the tips. The positive goes in, the 10 amps, and the common. Well, the black goes there. What are we going to do? We are going to make a bridge, a series circuit. Ready? So we have the multimeter connected there. We are replacing the fuse. We are going to open the switch. And here it already shows us some initial consumptions. What are these initial consumptions? From the instrument panel, from the witness, and there is turning on. When I make a consumption drive, such a break bolt, there we see that the amperage increased because the consumption has increased. When I activate the signal, there I have the left, we see that there is a consumption and also it is intermittent. What is intermittent? Well, because it is working with the flasher. So to take a current reading, what I'm going to do is direct the current that goes to the turn signals. That is, I'm going to do the suspend the flasher. Ready, so what I did was bridge the orange cable with the brown one, and there I have the turn signals activated. 0.43 minus 1.67. That gives us 1.24. Then 1.24 divided by 2. That gives us 0.62. What does it mean? That here we have the consumption divided between the two left turn signals and the light bulb on the instrument panel. Now we are going to activate the right turn signals and let's see that the consumption is different. It measures from 1.67 low to 1.38. We have a difference of 0.29 amps and we have both bulbs. This means that one of the two turn signal bulbs, either the rear or the front, has a lower consumption. This type of lower consumption is what is causing the motorcycle to flash, the bulbs to flash faster. This happens because the flashes are designed for amp consumptions. They are already designed by the manufacturer. That is why we must use original spare parts. However, other types of spare parts can be used, yes, but since the manufacturer doesn't tell us the flasher how much the charge is, we must calculate it. The total consumption of amperage is calculated with the watt low, and for that we need to see the consumption element. In this case, it is 12 volts, 10 watts, and watts low is represented by the W for watt, the V for voltage, and the I for current. This will be the same as amperage. So it is represented in this way. Then, how is it clear? We need to know the I, which is intensity or current. So we solve for I, which is equal to watts divided by voltage. Let's substitute. So we have 10 watts, which is the power of a light bulb divided by 12 volts. 10 divided by 12, 0.83 amps. Generally, when we have a lower consumption in amps, it is very subtly because the light bulb or the consumption element has a lower voltage, that is, lower watt with which it should work. But which is what the manufacturer tell us. So we are going to verify this turn signal because this turn signal is generic, which in theory would have nothing to do because the plastics don't affect it. What affects is the bulb. So we are going to review it. Of course, not every time. It is because the light bulb or the elements don't have the voltage. That is, it happens a lot and it is very frequent. That is due to external agents. That is, sulfatations, cables about to brush, physical things that are normally things that pass on diagnosis to the electrical system. And see here the cause of the problem. As we can see, this socket is leaking on the inside and this can generate the false contact between the light bulb, and that is why it is sometimes generate the flashing. Because this light bulb is also 10 watts. It is not original bad luck. It is 10 watts and in practice it is a 12 volts 10 watt electrical component. It should generate the same consumption of amps. But it happens that is because this part is sulfated and see, it is a physical use. The physical usage affect the electrical operation quite a lot. So you have to always check these physical parts. So the hyperflashing that we had was due to a sulfatation issue. It wasn't a voltage issue, which is normal what occurs. Hey my friends from Fixer Motos, don't forget to like the video before leaving, subscribe to the channel and activate notification. Remember that this is a completely free training for you. Then I'm waiting for you in the next video. So until next time.